Solve the following equations and inequalities. Then graph the solutions on a number line. A. The absolute value of x equals 7. To solve this equation, let's recall what the absolute value means. The absolute value of a number is its distance from 0 on the number line. So the numbers that we're looking for are the numbers that are a distance of 7 from 0 on the number line. Well, in fact, there are two such numbers. 7 is a distance of 7 from 0 on the number line, but negative 7 is also a distance of 7 from 0 on the number line, which means the solutions to this equation would be x equals 7 or x equals negative 7. Now, in B, we want to find the numbers that are a distance of negative 7 from 0 on the number line. Well, in fact, there are no such numbers. Since a distance has to be positive, there is no number that's a distance of negative 7 away from 0 on the number line. So this equation has no solution. Now, let's consider these two inequalities. Take a moment, pause the video, and see if you can solve them. So now in part C, we want to find the numbers that are a distance less than 7 away from 0 on the number line. Well, if we imagine a number line, the numbers that are a distance less than 7 away from 0 on the number line would be the numbers between negative 7 and 7, since all of these numbers are a distance less than 7 away from 0 on the number line. Now, in order to represent our solution, we would have to write a compound inequality, because our solutions have to be both less than 7 and greater than negative 7. So our solution would be x is less than 7 and x is greater than negative 7. And it's essential that we include the word "and" to show that our values of x have to be both less than 7 and greater than negative 7. Our values of x have to make both of these inequalities true in order to make this absolute value inequality true. Now, part D is quite similar but different. So in part D, we want all of the numbers that are a distance greater than or equal to 7 from 0 on the number line. The numbers that would be a distance more than 7 away from the number line would be here to the right of 7 and here to the left of negative 7, since these numbers are a distance more than 7 away from 0 on the number line. So now to write these solutions to this inequality as a compound inequality, we would have to say that x is greater than or equal to 7, or x is less than or equal to negative 7. Of course, x can't be both of these things at the same time, but the values of x that solve this inequality here are the values that are greater than or equal to 7, or those less than or equal to negative 7. And again, this word "or" is essential in our solution. So, now take a look at problems E and F, pause the video and try to solve them. Now we can see that the inequalities in E and F are quite similar to C and D, and yet they're slightly different. In E, we have the absolute value of x is less than 7. Well, that means this quantity here, inside of the absolute value, it has to be less than 7 and greater than negative 7, just like what we had here in C. This number x had to be less than 7 and greater than negative 7, which means in E, x plus 3 has to be less than 7 and x plus 3 has to be greater than negative 7. And now we can solve each of these inequalities as one-step inequalities. So we would simply subtract 3 and get x has to be less than 4 and x has to be greater than -10. So these are the solutions to our absolute value inequality. And if we graph those solutions on a number line, I'll put down -4 and 10. We want x to be greater than -4, which would be these values to the right of 4. And we want x to be, I'm sorry, I made a mistake here. Let me correct that. Let me try again. -10 and 4. So we want the values of x that are less than 4. So that would be these values. But our values of x also have to be greater than -10, which would be the values to the right of 10. And since our values of x have to be both less than 4 and greater than -10, our solutions would be the values in between -10 and 10. Now for part F, again, if we consider the relationship of problem F to problem D, we'll see that in D, the value of x had to be greater than or equal to 7 or less than or equal to -7, which means in problem F, this quantity x plus 3, it has to be greater than or equal to 7 or x plus 3 has to be less than or equal to -7. And to solve each of these inequalities, we will subtract 3 from both sides of the inequality. 7 minus 3 is 4. And here, -7 minus 3 is -10. So here, our values of x have to be greater than or equal to 4 or less than or equal to -10. So, if we graph these solutions, we want the values of x that are greater than or equal to 4, which are the numbers to the right of 4, or the values that are less than or equal to -10, which are the values to the left of -10. So our solutions are either greater than or equal to 4 or less than or equal to -10. Now one final comment, if we look at problems E and F, you might ask yourself what's in the middle between -10 and 4? Well, the distance from -10 to 4 is a distance of 14, which means half of this distance would have to be 7. So what number is 7 away from -10 and 4? Well, that number would be -3. -3 is a distance of 7 away from -10 and 4. And we'll notice that if we look at our absolute value inequalities, we have this x plus 3. Well, the x plus 3 on the inside of the absolute value is actually telling us that we're trying to find the values that are distance less than 7 away from -3, because x equals -3 is the value that would make the inside of this absolute value equal to 0. So again, in problem F, -3 is exactly a distance of 7 away from -10 and 4. But to solve this absolute value inequality, we would want all of the numbers that are distance greater than or equal to 7 away from -3 on the number line.